Our game is called the game of math. Awesome game. Love it. It's one of the best games. Okay, physics is what's that? Can you teach physics instead, please? I'd love to. Physics is fun. But yeah, in order to do physics, you have to be able to do this. All right, here we go. Okay, good. Now let's. I want to show you a trick. This is, you should feel privileged. This is a trick that I wasn't going to show you until chapter 7, but I'm going to show you chapter 7 anyway. So why not learn it now? Okay, there is an easier way. What we're going to look at today, let me kind of give you just a little understanding of how does this relate to what we've been doing. Okay, 6-4. You want to look at this in terms of sections. 6-4 is the one where you've got those 3 assignments on factoring. 6-4 is like at least half, if not more, probably 2/3 of all of chapter 6 essentially is section 6-4. 6-4 deals with 2 things. It deals with factoring polynomials, which we've talked about, and using factoring polynomials to solve polynomial equations. That's what we're going to look at today. Solving polynomial equations is always going to be easier than factoring polynomials, and you'll see why today. It makes things easier. For one thing, here's one prime example of why this is an easier thing to do than what you've been doing. Now, if we were going to factor this expression, we would have to factor this as a difference of squares, right? Everybody agree? Okay, but do we really need to factor that to solve it? No, this is chapter 5 stuff. What do we do with this to solve it? Add 16 and then square root, because really what we're doing, and this is good review, we're going to isolate x here. Whenever we can point to a single x, which we can do here, here's our single x, I can always isolate it by reversing order of operations, right? Okay, so we've done this a bunch. This is a case where we would just add 16 and square root both sides to get what? No, plus or minus. Okay, and the reason for that is we've talked about why that is, but let's compare that to maybe more of a chapter 6-like problem that we can do in a similar way. What about one like this? It looks really similar. Now, if we followed the same pattern here, what would we do to isolate x? Subtract 343 would definitely be step 1. Okay. Now what would the next step be? Cube root. Yeah. Instead of square root, we're going to cube root. Okay, but we got to be careful with this. Now I don't mind if you guys kind of cheat ahead and use chapter 7 stuff on this, but you really got to be careful with it because there's some stuff we're going to talk about in chapter 7. It's not a big deal, but it's important. I mean, it's not. It's a very big deal in that it's important, but it's not hard. If I cube root both sides, I'm really just doing this, aren't I? Okay? If I cube root both sides, what is the cube root of x cubed? It's x. Good. Okay, so we get x equals. What is the cube root of negative 343? Okay, it's not I. This is what's different about it. Okay, it turns out that you can take a cube root of a negative number. Okay, in fact, you can take any odd root of a negative number. You just can't take even roots of negative numbers. So there's 2 things I want you to know about here. One of them is that whenever I square root something, so let's go back to that last problem. If I have x squared equals 16, what I'm really doing when I take a square root of both sides, there's an invisible 2 that really should be there, but we just don't write it because we get lazy because we do square roots so frequently that we just don't write it, but it's there. So a square root is really a second root, and a cube root is really a third root. Well, 2 is an odd number, and 2 is an even number, and 3 is an odd number. Anytime the number on the root, on the radical sign, is even, we call that an even root. And those are the ones that you can't take a negative number of. Bad grammar, get the idea, right? Odd ones we can. Okay, the other thing that's different about that is, whenever we take an odd root of an equation, both sides, that's where you need a plus or minus, but you don't, did I say odd? I think I meant, let me start that sentence again. I think I said odd, I meant to say even. If I ever take an even root of both sides of an equation, I have to also put a plus or minus, but I don't with an odd root. Okay? So the answer to this is, well, what is it? What's the cube root of 343?
-7.
Okay, for positive 343, it would be positive 7. For negative 343, it's just negative 7, isn't it? Because think about that. Negative 7 times negative 7 is positive 49. Times negative 7 again makes it negative, right? So it really does work to just take a negative number to an odd power and you get back a negative result, right? So this answer is just negative 7 only. Okay, make sense? Okay, do you know how to do a cube root on a calculator? On the graphing calculators, it's like this. You go to math menu, and it's right there, cube root number 4. Okay, so I can do cube root of negative 343, and I get the answer negative 7. Okay. So how could we do this one the chapter 6 way? You don't have to. I don't care if you do, but I want you to at least see how it works. In a chapter 6 way, to solve this equation, x cubed plus 343 equals 0. Well, I could write that as a sum of cubes, couldn't I? Right. I could write that as something cubed. I need a little more space for this. I could write that as something cubed plus something cubed equals 0. What's the first something? X. Second something is a 7, right? And then we have a pattern for that, for a sum of cubes. Remember, our sum of cubes pattern is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. You just have to know those, right? So if I plug in my a's and b's, for this one I'm going to get a plus b would just be, that's my a and that's my b, right? So I would just get x plus 7 times a squared minus a times b, 7x, plus b squared, 49. Okay, so now we have factors. If I set these equal to 0, right, we know that here you're going to get x equals negative 7, right? If I set it equal to 0 and solve. Now what about this one? Boy, that's bad. It's writing in the wrong direction. It's pretty bad writing here. But this one I could solve using the quadratic formula, right? Do I need to? We don't. We don't, because we know that this second quadratic factor in that pattern never factors, and it never has real solutions. They're always imaginary. We would find out pretty quickly if we didn't remember that, though, and we tried to put this into the quadratic formula. We would just get x equals negative b would be 7, right? Plus or minus the square root of 7 squared is 49. Minus 4 times 1 times 49 would just be 196. All divided by 2. But look at this. You can already see we're going to have big problems. What's going to happen when I subtract 196 from 49 inside the radical? I'm going to get negative for sure, right? So I know right away that this one is not going to give me any real solutions. I'm going to get i's. And the question only wants real solutions, right? Only real zeros. So that's how we just get our 1, 7. Or negative 7, sorry. But isn't it easier just to do it that way? If you're comfortable with that, do it that way. Okay. All right. Moving on. Okay, we can skip that. Okay, what about this guy? So the first set of problems is really simple. Those are the ones where you only have 2 terms, and you can always, if you choose to, solve those kinds of polynomial equations by isolating x. Okay? This is a little different. What am I going to do here to start with? Say it again. Okay, I'm going to subtract 9x and subtract 3 from both sides. In other words, I want to set it equal to 0. Put it in standard form. So if I do that, if I subtract 9x from both sides, here I'm going to get my x cubed plus 7x squared. Now what's negative 27x minus 9x more? Here's my negative 36x, and then I've got negative 249, subtract 3 more.
Isn't the part of x supposed to be?
It is supposed to be cubed. I was just checking to see if you paid attention to everything you were. That's great. Okay, so now what? I've got a 4-term polynomial on the left side. How do I deal with a 4-term polynomial? Now remember what my whole motivation for factoring is, right? Excuse me. Yeah, choking. I get so passionate about math. So I have to break this thing apart into small enough pieces that I get into factors so I can set the factors equal to 0. There is no magic formula. There's no cubic formula I can plug these things into. I've got to factor it so I can set the factors equal to 0 and get those mini equations that are easy to solve, right? But so then the dilemma here is, and this is what the stuff you've been practicing is all about, how do I factor a 4-term polynomial? What's my strategy? Say it again. If there is one, I'll take out a greatest common factor, but there isn't one there. What do you mean the table thing? Oh, okay. Well, no, the synthetic thing? No, not yet. We're not. That's the next thing we'll learn. But it doesn't really help us here. Grouping, yeah. And the cue to remember that, I think, is you can only group something with an even number, so I can get the same number of terms in each group. Well, this already has 4, so I can group it into 2 groups of 2, right? So we'll group this into group 1 plus group 2 equals 0. First group is just the first 2 terms, so x cubed plus 7x squared. Second group, second 2 terms. Now what do we do? What do we do to the first group? What's that mean?
I don't know. Oh, take out like what all the you take out like x squared.
Okay, you can take out the greatest common factor, right? I want to undistribute or factor out the greatest common factor. I can't take any numbers out, but I could take out an x squared, right? So if I undistribute an x squared, Scott, what's going to be if I undistribute an x squared? What am I left with in this first one if I undistribute that? X, good. Plus 7, very good. Okay, everybody see that? Okay. So the second group has to, if factoring by grouping is going to work, it has to fall into the same pattern. Now, if it's going to work, here's the other kind of procedural question. If you're doing this correctly, what do I write down next? What has to be the same in both groups? The blue one, right? The x plus 7. The leftover bigger factor has to be the same. So I can immediately write an x plus 7 there. And then the question is, does it work? Well, remember, there's kind of a good way of testing it. What number would I have to distribute to the x to get negative 36x, obviously? Negative 36, and does that work for the 7? Well, negative 36 times positive 7 is negative 252, so it works, right? So factoring by grouping worked. Now what's the answer? What's the factoring by grouping answer, at least? What are the 2 factors we get by grouping? Okay, good. Now, because look here, I've got, does everybody see why? This is the part I still feel like people don't, I mean, it's okay to just know the pattern, but it'd be nice to know why this works. I've got this red, I've got a red factor times a blue factor plus a different red factor times the same blue factor. So the blue factor is the one that's the same in both groups, so I can undistribute it from each group, right? I factor it out. So I'm left with then x plus 7 times what's left behind when I take that out. X squared plus negative 36, right? Those are gone. So now I factored it on the left side. Okay, here's the good news. Here's why these get easier. Because now, if I were factoring this completely, I'd have to keep going. But I don't need to here, do I? I've got this down to small enough factors, small enough pieces, that if I set those equal to 0, I can solve those mini equations and be done with it. I don't have to go any further with the factoring, right? So what do I get? If I set the blue factor equal to 0 and solve, what's the solution? -7, right? Everybody see that? X plus 7 equals 0. I just subtract 7 from both sides. There's one of my zeros. Okay, what about the red factor? If I set that one equal to 0, what are the two steps to get the x by itself? Add 36, square root. So x equals plus or minus. So I get 3 zeros. -7, -6, and 6. Just separate them with commas. Right? Okay, we good? Yes. Yes, you may. Okay, so there we go. Okay, so real quick, get out your notebooks and just, I want to see if you can take just a minute or two and see if you can get this one set up and at least get the group set up and get them factored. If anybody needs scratch paper, let me know. I'll come around.
I don't hear though. Oh.
You betcha.
Oh, I'm sorry.
Yep. Paper snob. Okay, so what's first step while you're working here? What's the first step? Good, bring everything to one side, set it equal to 0, good. Okay, so we got everything on one side, right? So did everybody get this? X cubed plus 12x squared, what do we get? Minus 14x
Oh, man.
minus 168. Okay, so how many terms? 4. So how do I, what strategy? Grouping. Okay. First things first. What do I do first? Okay, greatest common factor. What is that for the first group? X squared. Take out x squared, leaving me with what?
12.
Okay. So what do I write next? Okay, I know that if it works, that's x plus 12, so what would that need to be? Does that work?
Yes.
It does. It does. Negative 14x works, right? And negative 14 times positive 12. 12 times 12 is 144, plus another 2 times 12, another 24. 68. It's negative, right? So it works. Okay? All right, so what does factoring by grouping give us then? What two factors?
X plus 12.
Good. So we get x plus 12 times x squared minus 14 equals 0. Okay, so now we're essentially done. I can solve those two mini equations if I set those equal to 0 really easily. If I set the blue equation equal to 0, the blue factor, what do I get? Negative 12. What if I set the red factor equal to 0? Plus or minus square root of 14. Good, because I'm going to get x squared equals 14, right? So x equals plus or minus square root of 14. So I get 3 real zeros. Okay. Plus or minus square root of 14. There's 2, and there's the third. Right? Okay. All right, next kind. This. Okay. This one looks a little different than what we had before, but it's the same kind of thing. There's a single x there, so I should be able to isolate x. Now, there's a chapter 6 way of doing this by using a difference pattern, but we can avoid that if we just isolate x. But this is something we haven't talked about yet. How do I do this? To isolate x there, what's the first step? Add 81. So I get x to the 4th equals 81, right? Okay, now what? Okay, yeah, we would just call it a 4th root. Okay, we'll take a 4th root of both sides. Is that an even root or an odd root? It's an even root, and so it works because that's positive, but if it were negative, it wouldn't, right? But because it's an even root, what do I have to include in my answer? Plus or minus. Okay, so we're going to get x equals plus or minus the 4th root of 81. Now, a 4th root is kind of a weird deal. A 4th root, we're going to talk about that more in chapter 7. There is a way to do a 4th root on your calculator, and I'll show you. You can do this. So one way to do it is you have to push the number first for the kind of root that you want. Well, this is a 4th root, so I would push a 4. And then I go math, and then the 5th option where it says x root. So it's going to take the number that I entered, and that's going to become the kind of root. So if I choose the 5th option, look what it does. 4th root, and then I can put my 81 in the middle. And there it is, 3. Okay. Now, I got to do plus or minus, though, don't I? Right, I need the plus or minus, but I get plus or minus 3. Another way to do that would be if I take 81 to the 1/4 power. That also gives me 3. Okay. But there's even an easier way. A 4th root is really just a square root of a square root, right? So I could do something like this. I could start with my x to the 4th equals 81, and what if I square rooted both sides? What's the square root of x to the 4th? In other words, what squared is x to the 4th? X squared. Yeah, if I square root both sides, I'm going to get x squared equals plus or minus 9. X squared equals plus or minus 9. So I get to take both of those answers. If x squared equals 9, what are my solutions? 3 and negative 3. What if x squared equals negative 9? Can I square root a negative number and get a real result? I'm going to get i's, aren't I? Right? So that one wouldn't give me any real solutions. Okay, see that? Okay, so that's, I think either one of those ways is fine. Now, the chapter 6 way, I want you to see the chapter 6 way, and you might like this better. It's up to you. Oops. Okay, here's the chapter 6 way. So, whoops. So if I have x to the 4th minus 81 equals 0, the chapter 6 way is when I'm factoring a polynomial with 2 terms, I got to use a sum or a difference pattern. But what's the difference pattern? It's a difference. What's the difference pattern that's going to work? Or a difference of cubes or a difference of squares? Squares. I can't really write x to the 4th as something cubed, but I could write it as something squared. Right? I could write this as something squared minus something squared. What's the first something? Yeah, x squared squared is x to the fourth. 9 squared is 81, right? So then this splits apart using my pattern. A squared minus b squared. Remember, that just equals a plus b times a minus b, right? Oops, that's an a, right? So that's my a and that's my b. So I'd get x squared plus 9 times x squared minus 9. And when I set those equal to 0, don't you see I'm just going to get these results, right? Okay. Don't you like the left way better though?
Yeah.
Yeah. Okay. What about this one? Okay, what about that? 3 terms, right? 3 terms. So how do I deal with a 3-term polynomial? How do I factor that? Remember? It's got to be a quadratic form. But the good news is that means I don't have to factor it. I don't have to do any factoring on this at all. I don't want to. If it's really easy factoring, I might choose to, but I don't have to do any. So the question is, that I want, you probably are okay with this, but I want to just review this real quick. How can I rewrite that in a way where it's definitely quadratic? Right now it looks not really quadratic. I've got an x to the fourth and an x squared in it. For it to be quadratic, I have to be able to write it in a quadratic form, which means a times something squared, right, plus b times something to the 1 plus c equals 0, right? So can I do that?
Yeah.
What's my something this time? X squared, right? If I break this into pieces of x squared instead of x to the fourth, it works. Okay, what's my a and what's my b and what's my c this time? A is what? 1. What's b? Negative 13. C, 42, right? Okay, so then this just becomes 1 x squared squared minus 13 x squared plus 42 equals 0. Well, that's quadratic. I know a, b, and c. It's in standard form. I can use the quadratic formula, right? We know from the quadratic formula that something always equals, if it's written in a quadratic form, negative b, so that's positive 13 plus or minus the square root of b squared minus 4 times a times c divided by 2, right? What's the something this time? Right? Whatever is showing up in here is what we're setting equal to that sum in the quadratic formula. So it's an x squared this time, right? So what do we get from that? Okay, well, if we simplify this, I get 13 plus or minus, that's just 169 minus 168. That's 1. What's the square root of 1? 1. So we get that. Right? So if I take the plus, answer, I get x squared equals 13 plus 1 is 14 over 2. What's that? 7. So one answer is x squared equals 7. The other quadratic formula answer, if I take the minus, 13 minus 1 is 12, right? Divided by 2, 6. Okay, so Dylan, what am I going to get from my 2 solutions from this one? There's one of my, put that away. So if I square root both sides, what am I going to get? Anybody? Yeah, I got square root both sides. So if x squared equals 7, then doesn't x just equal plus or minus square root of 7? There's 2. How about this guy? Plus or minus square root of 6. Yeah. So I get 4 zeros. There they are. Okay. Didn't have to do any factoring. Now, I could have. I actually could have factored this if I would have tried to find magic numbers that multiplied to 42 and added to negative 13, but I didn't need to.
So the formula is the stuff to do? Like
Yes.
that's always in it?
Yep.
So and the inside of it, isn't it always gonna be x squared or?
Well, it's, for us, it is, yeah. I mean, it's, well, you could, later on, you might, well, what if you saw one like this? And just hypothetically, what if you saw I'm not gonna give you one like this, but just see if, what would you do? If you had something like x to the, let's say the x to the 8th minus 3x to the 4th minus 40 equals 0. Is that quadratic? Well, it could be, if I took pieces of what? How could I write this as something squared minus 3 something to the 1 minus 40 equals 0? What would the somethings be this time? No. I take a power to a power, I multiply the exponents, right? X to the 4th, yeah. Right, so that's still, we could cheat on that and use the quadratic formula, but then when we're done, we're gonna get solutions for what x to the 4th is equal to. We have to solve those, right, go further with those. But you get the idea? I won't make you do, I mean, we're just gonna do x to the 4th ones here, but you get the idea, okay? Okay, so this is the granddaddy of all. But this is, it's not hard, it'll be fine, it's not that big a deal. Okay, so what do we do with this one? Get it all on one side, sure. Okay. So that's gonna give us negative 5x to the 5th. Let's see, plus 25x cubed plus 250x equals 0. Okay, that's a little better. We got it in standard form. Now what? Okay, this time it's a little different, isn't it? What do we don't have an x to the 4th and an x squared and just a constant. So what do we probably need to do here? Yeah, we're going to factor out a greatest common factor. Good. Now there's a little trick that goes with this too. Whenever I factor out a greatest common factor, I always want to keep the sign of the leading term. So the leading term is negative. So we'll factor out a negative, what's the biggest number that goes into all those numbers? 5 does, yeah, they all end in 5 or 0, so they're all divisible by 5, right? So I can take out a negative 5, and what power of x? Just x to the 1, good. So take out a negative 5x, leaving me with what? If I undistribute a negative 5x, what are we going to get? Dylan, what am I going to get if I undistribute a negative 5x? Factored that out of this. Negative 5x times what is negative 5x to the 5th? 4th. X to the 4th. Okay, what's the next one going to be? Negative 5x times what is positive 25? X squared. Good. And then finally, negative 5x times what is positive 250? X? Negative 50. Good. Okay? Good. Right? That's going to use the same trick that we did last time, isn't it? We can rewrite this as a quadratic form with x squares. Right? Okay, this time let's not bother with the quadratic formula because there's some magic numbers that work really easily here. What's the value of a in this quadratic expression? 1. When a is 1, magic numbers are easy to find. We just want to find numbers that multiply to c and add to b, right? So what two numbers multiply to negative 50 and add to negative 5? Negative 10, positive 5. Good. So this is going to break apart into magic numbers, negative 10 plus 5. What's my first term going to be? X squared thinking that all I have to do now is just solve those mini equations. Well, when is negative 5x equal to 0? When x equals, so this one's, yeah, x is 0, right? There's 1, 0. Okay, what about this one? I get x squared minus 10 equals 0 when x squared is 10. So what's x? Plus or minus square root of 10. Okay, what about this guy? So x squared equals negative 5. Getting i's, aren't I? By square root, I'm going to get i's. Everybody agree? So you can forget about that one. So my only answers are 0 and plus and minus 10. Make sense? That's it. You can do those. You can do anything up through 6 more. Yeah, I think so. Yes.